Good afternoon, everybody, dear ladies and gentlemen. I'm pleased and honored to present today, on the occasion of the EASA Rotorcraft Symposium, an overview of the ongoing REGA IFR helicopter activities in Switzerland. With your permission, I would like to report on the following helicopter-specific IFR topics that REGA has been working on for more than a decade now. My agenda is as following: short introduction about REGA, the HEMS, ACE, ARIOS project, ARIOS Insight, the RMPar, fixed radial transitions, and the summary. REGA was founded in 1952 as an association and is now a foundation with 3.6 million supporting patrons. The 12 helicopter bases are distributed in such way that the REGA helicopter can provide medical assistance on site within 10 to 20 minutes. REGA holds the necessary operation license for both the helicopters and the aircraft, and in order to support its mission as its own flight school, a Part 145 maintenance and a Part 21 design organization. The current fleet of helicopter comprises 7 Airbus H145-D2, 11 IW109s, and for pilot training, an H125 helicopter. From 2023, the fleet will be strengthened with an additional 3 AW169, we call it Icebird helicopters. The now modern AW169 helicopter will be equipped and certified for allow IFR flights in icing condition and for the RMPar procedure. That's why we call it Icebird. All REGA pilots hold a valid IFR licenses. REGA's HSCM helicopter crew members are also trained in assisting the pilot in IFR flight operations and train with their pilots on the regular basis. The REGA AW109 full flight simulator in Zurich is available to the crew for this in-house training task. With the delivery of the 3 Icebird helicopters in 2023, the REGA will have access to its new AW169 full flight simulator at its disposal in the Lufthansa's new simulator center at Zurich Airport. The 3 Challenger 650 ambulance aircraft complete the fleet and are operated exclusively for air medical missions and are approximately 4,500 hours per year in the air. Since the very beginning, REGA helicopters rescue activities, isolated air rescue missions in the Swiss Alps were also carried out at night. This traditional of flying primary missions to non-presurveyed sites at night with rescue helicopter has been steadily improved over the time. Today, all REGA bases are available on a 24-hour service. This means that the first A stands for any time. With the provisions of more powerful helicopters by the manufacturers, the possibility of carrying out rescue operation in the Alps more safely has also improved. Today, rescue operation can be carried out in good weather conditions, both during day and night, such as on the north face of the Eiger with the rescue winch by well-trained crews. Thus, since the mid-70s, the second A have been accomplished, which stand for anywhere. With the new technical possibilities, the intention of carry out rescue flights at any time and anywhere continuously realized. But what about to perform rescue missions under almost any weather condition? Poor visibility is still most common reason for a REGA crew to turn down a mission. Even the 600 patients who cannot be flown for weather reason are entitled to optimal medical care by air. To be able to help even more people in distress in the future, for many years, REGA has pursuing its vision of all-weather operation for rescue missions. The gene of continuous improvement is the driving force behind REGA's participation in various applied EU research projects to improve helicopter IFR flight procedures. The EU-funded helicopter projects aim at improving emergency medical helicopter service by applying EGNOS, developing and applying procedures that take into account the unique flying dynamic of modern helicopter, IFR helicopter, and the access to the GNSS navigation solutions. As the results of this EU project show, operational, sensible approach and departure minima cannot be realized in topographical, difficult terrain such as in Switzerland with the current applicable ICAO PANSOP design criteria. We collaborated with the Swiss Air Force and Skyguide to develop a network of GNSS-based instrument flight procedure and instrument flight routes. The routes are called Lowflight Network, which enable us to perform rescue missions in almost any weather. The Lowflight Network is designed for establishing a practical, efficient, and a quick connection between all critical landing points for air rescue throughout the country. The Lowflight Network and his PINs procedure will be further expanded in the coming year. The Swiss Parliament has decided by a large majority that the Lowflight Network, including the connecting PINs procedure to the central hospital, is of national interest and for the medical care of the population and is therefore co-financed by the federal government. The following example of a typical topographical situation, the area around Interlaken Hospital, is intended to show where the described problems can be found and how an attempt is made to find a solid solution with the help of the various stakeholders. Interlaken Hospital is located between the Lake of Thun and Brienz in the Bernese Highland. The area is well-known tourist destination and the hospital is therefore an important medical infrastructure, especially in winter when insured winter sport enthusiasts benefit from the service offered by the hospital. As can be seen from the bird's eye view, Interlaken is bordered by the mountain ranges to the south and north of the lakes. Under such circumstances, the creation of an instrument, approach or departure procedure is a demanding task for the procedure designers. In particular, the decisive safety distance of the terrain often hinders the achievement of a low approach minima that is interesting for the flight operation. Interlaken Hospital has 3 landing possibilities. One of the landing sites is elevated. During the ski seasons, it often happens that all 3 landing sites are occupied by the rescue helicopters. Particularly in the winter half year, however, Interlaken Hospital is below a stratus layer. Above this layer, it's good winter weather, and below the layer are VFR conditions. I have already explained to you the reason why REGA pursuing the AAA as a strategy, anytime, anywhere, and almost any weather. Allow me to go briefly into the past of REGA's commitment to demonstrate the development of the technical solutions. In 2009, REGA participated in the HEDGE program and with the support of Steve Hickok, created the first helicopter LPV approach in Switzerland. Due to the lack of ICAO LPV criteria, the LP was created in accordance to the then valid FAA criteria. The achieved approach minimum of 347 feet above ground level was exceptional. With the AW109 Da Vinci, several test flights were successfully carried out in the presence of experts from Leonardo, AgustaWestland, and EASA. 6 years later, in the following up project using RMP.3 and the radius to fix, a demanding procedure for the flight management system and the 4-axis autopilot was further developed at the Interlaken Hospital. In the meantime, the LPV procedure criteria were published by the ICAO and applied to this procedure. Unfortunately, the approach minima according to the former FAA criteria had to be raised from 347 feet AGL to the new PANSOPS criteria and resulted in a minimum of 950 feet above ground level. Even this LPV procedure, now adapted to the ICAO rules and provide RF flag, could be flown very accurately under VFR condition by the AW109 Da Vinci helicopter with the approved equipment and such as the flight management system and the autopilot. Various CESAR projects support the further development of the future-oriented helicopter-specific IFR procedures using EGNOS. With the PROW project in particular, we were able to develop a RMPar approach and departure procedure at Samaden Airport. That's the highest airport in Europe, 5,600 feet, tailored to the existing operation capability of the AW109. As past developments have shown, the conventional LPV procedure can only be used to a limited extent under the existing topographical conditions. The table gives an overview of the various approaches and their minima at Interlaken Hospital as an example. As the comparison between the approach and procedure shown, better approach minimum can be achieved when using RMPar. As the results of various projects have shown, useful approach and departure minima, obstacle clearance altitude, in the demanding environment can only be achieved with the new helicopter instrument flight procedure, helicopter RMPar. So, is it a problem if better approach minimum are achieved with RMPar? It's a classic chicken and egg situation. Helicopter RMPar and helicopter PINS RMPar procedure design criteria do not exist. As no helicopter RMP procedure exists, because no criteria are available, OEMs will not produce RMPar approved helicopters. REGA wants to change this unfavorable situation by developing the missing specifications together with experts in the project ARIOS, the responsible NAA, Swiss Federal Office of Civil Aviation Authority, the air navigation service provider Skyguide, and the OEM Leonardo and EASA have all committed to give the project the necessary support. And I would like to thank our partners RITE for this support and their dedication. ARIOS stands for Advanced Rotorcraft IFR Operation in Switzerland. The vital part was to develop procedure criteria for helicopter RMPar, approach and departure procedure, and the acceptance of these procedure criteria by the Swiss Federal Office of Civil Aviation for the ARIOS project. We established RMPar procedure in Samaden as well as in Interlaken Hospital. The verification, evaluation of the flight accuracy, the most important thing of this procedure under normal and abnormal conditions. And of course, as a company, we would like to use the procedure. Therefore, we need the preparation of the required documents, operation manual, training manual, etc. for the helicopter RMPar ops. In order to verify this procedure, we had a comprehensive verification. The procedure were flown with 3 helicopters from Leonardo, an AW189, 169, and of course our good bird 109. Using the example of RMPar, point 1 approach and departure at Samaden Airport, the advantage of a helicopter-specific procedure can be clearly demonstrated. For the verification of the total system error, composed of the sum of the navigation system error, the path divination error, and the flight technical error, we use the flight recordings evaluated by Skyguide expert. The GNSS signal recording was done with the mobile GNSS multi-constellation Java receiver, independent of the onboard system. I am pleased to present the first results of the detection flights based on the example at Samaden Airfield in Engadin. So RMPAR departure from the unlight non-instrument runway 03 at Samaden has been established with a navigation performance of 0.1 nautical mile. This means that during the takeoff climb, a reversal turn is initiated and thus follows the valley opposite to the takeoff direction, heading south over Italian territory to a helicopter low-flight level route to Lugano. A further connection to helicopter Lowflight Network to the north leading over the Euler Pass. The following example shows this RMPAR departure. The takeoff minimum would be 400 meters at day and 800 meters at night. According to the evaluation prepared by SkyGuide, it can be seen here that in the majority of the recorded departure tracks flown with the AW189 helicopter, the total system error is less than 10 meters in normal operation. This corresponds to the blue-colored line. The deviation climb curve is colored turquoise and this corresponds to a total system of error of less than 20 meters. The total system error during the RMPAR 0.1 transition over the Euler Pass remains always below 40 meters. The line with a total system error smaller than 40 meters are colored in green. You see here the distance, the recording, you see the waypoint's name on the top, and you see the deviation, which is always below 0.02 nautical miles. And we should have 0.1, which are the top and the lower picture boundary. In addition to the helicopter RMPAR departure, helicopter RMP approach to runway 21 and 03 have also been developed. These approaches also require navigation performance of 0.1 nautical mile. The approaches from the north over the Albula Pass includes a radius to fixed leg with simultaneously descent. The final approach segment has a 7.8 degrees glide path angle into the runway 21. And now you will see the benefit. The decision height in that high mountain valley is 250 feet above ground level, with a visibility for a non-lighted, non-instrument runway of 1,000 meters. For example, the today published RMP runway 21 approach to the runway 21 is 3,000 or almost 4,000 feet above ground level and requires a visibility of 5,000 meters. Of course, this is a fixed wing approach. Due to the topographical condition, the missed approach segment will be then constructed according to the RMPAR 0.3 criteria. As reported, we have flown the flight tests with the helicopter types Augusta 189, 169, and 109. I have listed the respective total system error of the flight path together on this page. Here you can also see the blue lines predominate all three helicopters, which corresponds to a total system error of less than 10 meters. An animated view of how the pilot received the RMPAR 0.1 approach to the runway 21 at Samaden. The image was created by integrating the recorded flight path data in the Google Earth. The helicopter is in the RF flag at the waypoint Zulu Sierra 680, which is on the glide path 7.8 degrees to remember. Here the helicopter is in about 2.3 nautical mile straight final leg to the missed approach waypoint. However, an important aspect is that anything less than precise than RMP 0.1 leads to altitude above the mentioned pass over the Albula or the Euler of more than 10,000 feet. And the mentioned FIPS, the full ice protection of the 169 has for the time being a limitation of 10,000 feet. As this verification flight shows, the advantage of an LPV is that the approach minimum can be significantly improved with a helicopter RMPAR. This means that emergency medical care by helicopter can be significantly improved in the future for both residents and tourists in the Engadine Valley. Which specification make it possible to achieve lower approach minimum, as in the example of helicopter RMPAR procedures? Above all, the specific obstacle clearance are smaller on the RMPAR approach, and departure makes the lower approach or departure minimum possible. What is the situation in en route? According to the monitor data, the evaluated total system error in cruise flight as well as in the approach always been less than 10 meters. A reduction of the required ICAO PANSOPS buffer value can only be realized after a large worldwide measurement is available, which will be costly and time-intensive. As an alternative, we have taken a closer look at the use of fixed radio transition in the en route. The fixed radio transition is intended to be used en route procedure above flight level 195. Why not use them for the helicopter low-flight net routes? Also, in the clarification about the possibility of using fixed radio transition for the helicopter low-level routes, we chose a pragmatic approach. First, we checked whether the flight management system installed in the AW109 can apply fixed radio transition. Leonardo and Genesis confirmed that the AW109 equipment is capable of performing fixed radio transition en route. Skyguide provided coding of the low-flight airway Kilo Yankee 258 as experimental, using the fixed radio transition with a radi of 1.2 nautical miles up to 2 nautical miles. In order to be able to use the radi of up to 1.2 nautical miles required for the helicopter low-level route, Jeppesen had to adapt the existing coding system to the new, smaller fixed radio transition radi. What is the difference? What is the difference between radius to fix and a fixed radio transitions? A radius to fix, the normal way we are using, is mostly used in the thermal environment only due to the use of pass terminators, the RING 424 standard. Intended for obstacle clearance purpose, and two waypoints, the start and the end of the turn, as well as the arc center. It's only usable in one direction and can be in altitude and speed and starts at the end of the turn. So that means it's very limited for the procedure, mostly on the departure, on the approach. A fixed radio transition is an en route environment where no pass terminator like the RF can be used, intended for separation purpose by ensuring repeatable, precise en route turns without the difference in turn anticipation due to individual aircraft or avionics. Obstacle clearance benefit can be harvested. It's used one waypoint. Of course, we have also done additional test flight, and this is self-explanatory, that these flights have been used by the 109 helicopter. And also here, you can see that the total system error is below 10 meters, which is far below the required 0.3 nautical miles. We have recorded, of course, both ways. There are two flights going from the Lima Sierra 111 to the Lima Sierra, and then backwards. And you see that the turns and as well as the distance we have been using are well in the limit of the required 0.3 nautical miles for the en route phase. As often is the case in research and development of project, new insights and new questions arises. Below are some questions that have not yet been answered regarding the fixed radar transition application on a helicopter route. IFP protection concept to be defined, not yet clear within IFBP. That's the instrument, that's the ICAO instrument flight procedure panel. How to manage the interface between two routes in case of a prescribed fixed radar transition. Fixed radar transition is always applicable if linked to a waypoint, and fixed radar transition can only be constructed by RMP system up to maximum 90 degrees turn angle. Charting and publication. It's an additional functionality for RMP, so how do we assure that all users are fixed radar transition capable, and how to restrict the use of fixed radar transition routes? I think in Switzerland that will be no problem, as the low-flight networks are only for blue light organization, the Swiss Air Force or police. Non-standard for publication yet. The PBM manual from ICAO only attributes fixed radar transition to RMP4, RMP2 and advanced RMP. RMP.3 for helicopter are not yet included. We have a discrepancy between RING 424 standard, which gives you a free selectable within 1 nautical miles resolution, but the PBN manual refers only to 2 fixed values for the fixed radar transition, 22.5 nautical miles and 15 nautical miles. The following activities were completed within the ARIOS project for helicopter RMPA.1 procedure at Samaden, or were sent to a competent authority for approval. The established RMPar and PINS ARP instrument flight procedure criteria, SFOC accept those procedures. The ATC ConOps is almost finished to 70%. We have done the flight validation in accordance to the manuals. We have done a GPS EGNOS performance assessment on site, as well as the meteo study of the airport. We are looking forward, or we have received as the RMP AR.3 approach for the 109 is already existing, it's in the manual, but what is missing is the RMP departure, and we have also the full flight simulator is accepted for RMP.3 approaches, and all the necessary documents are sent to the SFOCA. What activity do we have for the 2022? We are looking to get operational approval for the 109 RMPAR.3 departure and the missed approach. The missed approach for the time being is 1.0 nautical miles, which of course will then limit the approach minima. We are looking to receive the RMPAR operation in our ASC, and the FOSA is almost completed for the departure. You need a flight operation safety assessment for the RMPAR activities. And of course, we will have access to thanks to the support from Leonardo on the 169 RMPAR.1, and this time it's not normal operation, it's abnormal operation, which consists primarily at GPS outage. I come to the summary. I take the liberty to summarize the findings and evidence from previous REGA's activity regarding helicopter-specific IFR procedure. The available IFR helicopters equipped with digital autopilot and state-of-the-art flight management system can already fulfill the requirement for RMPAR under normal operation conditions. On the condition that EGNOS increase the availability, GNS failure to radio frequency interference is less than 10 to the -7. We can prove that throughout the measurement we have done throughout the last year. The probability of the GNS navigation failure, the estimation of the duration of a GNS failure, the topographical environment where the RMPAR procedure is located, and the relevant direction changes within the RMP procedure should determine which equipment is required to maintain the necessary navigation performance in the rare case of GPS loss during the RMP operation. It's PBN, performance-based navigation. Third, the availability of a GNSS multi-constellation and multi-frequency receiver for aviation is to be accelerated by the OEMs. Currently, there are no EASA specifications available to the OEMs for helicopter RMPar certification, which would be adequately take into account the dynamic flight characteristic of a helicopter. The existing specifications are primarily tailored to fixed-wing aircraft, and apart that, also no longer reflect the state of the art of the modern avionic and autopilot. The helicopter RMPAR fixed-rated transition procedure is design criteria draw up. The PANSOP specialist should now be incorporated in the ICAO PANSOP specification as soon as possible. I'm confident that this will happen, as several of these PANSOPs experts involved are members of the ICAO Instrument Flight Procedure Panel in the Helicopter Working Group, thus ensuring the necessary exchange of information on the Arius project. That brings me to the end, and I thank you for your kind attention.